Okay, good afternoon, everyone. My name is Ekamo Wanameti from Department of Geography, Chulalongkorn University. Well, my research interest is about hydrology, particularly about rainfall and runoff model. And recently, I'm more interested in the climate model to investigate the effects of the climate change in hydrology and chance of flooding, and also other related natural hazards. So for today, I will present the research that I did with my students. The research is about to use the climate model together with the radar data to investigate the characteristics of the summer thunderstorm in Thailand. Well, the summer thunderstorm, well, in Thailand it is a local event, but it can cause a lot of casualties, particularly in the north and the northeastern. For the summertime in Thailand, it starts from March until May. And after that, we have the influence from the monsoon, then the rainy season starts. So in this research, I focused on the thunderstorm before during that time. So here you can see the examples of the casualties from this type of storm. And basically, this storm is generated by the convective storm cells, because at the time in Thailand it is very hot, and it generates a lot of thunderstorm cells, mainly in the north and northeastern. So in this research, we investigate the rainfall characteristic of this storm using WRF model and also the weather radar, and then see the effect of the ENSO phase on the intensity of this storm. So this is our study area. We focus on the upper northeastern part of Thailand, which covers the area about 34,000 square kilometers. And on this map, this is the domain of the WRF model that we use in these studies, that we have two domains which cover half of the countries, and the locations of the rainfall stations are shown in the blue dots, and also the red dot shows the radar station that we use to obtain the data for these studies. And these are the details of the simulations that we have that we used. The reanalysis data from NCEPs, and then we downscale it into 9 kilometers and 3 kilometers for each domain. And at first, we need to define the suitable physics options for our study areas. Here we test the cumulus scheme because these schemes are very important to understand or to simulate the thunderstorm. So we investigate these 4 physics schemes, and the rest we use the scheme that has been studied in other research in Thailand. So with these 4, so these are the settings of our model. And next, the data that we use, as I said, we use the radar rainfall and also the rainfall from the ground station. For the radar rainfall, we use the one radar station from Skol Nakhon area, and the radar station has we use the C-band radar, and with the 15 minutes interval of data collections, and the distance that it can collect the data is about 240 kilometers, and the data is from 1,000 meters from the ground level using different elevation angle. And we also use the ground station to validate the radar rainfall and also to do the bias correction. We have 5 ground stations to validate the radar data. And we use the ZR relations from this research to convert the reflectance to rainfall intensity. So these are the results from the bias correction of the data. So you can see that the radar rainfall overestimates the rainfall from the ground station. And when we calculate the ratio, the correction factors, you can see that for all stations, then the correction factors is below 1, which means that we have quite, that the radar overestimates the rainfall at the rain gauge. And then we apply the bias correction factors, and we investigate 3 methods to do the bias corrections, that we use the mean values of the bias correction, and we also interpolate the bias corrections from each stations and then creates the bias correction map and then apply it to all the radar image. And also we also test another bias correction by combining these 2 methods. And the result shows that the method that we use, the spatial variations of the bias correction factors, yield the best result. So we apply these bias correction methods for our radar data. And after that, we use the radar data to validate the result from WRF model. And these are the results that we test with 4 cumulus parameterization schemes with various accuracy metrics. And well, we can see that if we focus on the errors, on the percent of the pixels that has a different error range, you can see that the cumulus parameterized scheme that is called BMJ result in the best accuracy, that about 77% of the whole area has the error less than 1 meters of rainfall. And also, if we look at the wind speed, this parameterization scheme gives the smallest errors. So that's why we use this scheme to simulate the summer thunderstorm in our study area. Apart from this, we also evaluate the performance of the WRF model regarding the distribution of rainfall. So we calculate the standard deviational ellipse of the rainfall from the radar data and compare it with the WRF radar. And you can see from the result here that if we have high overlapped area, so it means that the result from the model and the result from the radar can be comparable. And then we also evaluate the results for each parameterization scheme. But then the result from this evaluation shows a little bit different than what we have done before. That for each evaluation, you can see that the parameterization scheme of KF is better than other scheme. But however, at the end, we have to choose only one scheme. So we go for BMJ because it gives the most accurate results in terms of the rainfall amount. Okay, and here are the once we already chose the best schemes, then we use the WRF model to simulate the summer rainfall characteristic for 12 years from 2010 to 2012, and these are the results. So here we analyze the amount of rainfall for every 2 weeks, and it shows a clear trend that we have the rainfall amount, the daily amount of rainfall increase in every 2 weeks. And in the last 2 weeks of May, this is the period that the the summer monsoon already has a full influence, almost at the full influence to this area, then we have larger amount of rainfall. Also, we also calculate the numbers of the day with the heavy rainfall, and it shows quite clear trend too that we have more days of heavy rainfall with the time goes by. But you can see from in April, the result can be a bit vary. That the trends doesn't show increasing trend from April to May. Next, we also investigate the spatial distribution of the rainfall from the summer thunderstorm. And we calculate the cluster of the heavy rainfall and also the size of the clusters. And we see the pattern similar to the amount of rainfall that we have more cluster of heavy rainfall with time. And also the size of the heavy rainfall cluster also increase. But then this increasing trend is not very obvious compared to the numbers of the heavy rainfall cluster. And also in this result, you can see that in April and in May, the trend is not can be quite vary, especially at the first 2 weeks of April, that the chance to have various numbers of heavy clusters are quite large. So these are the examples of the maps that we obtained from the WRF model, and we identify the cluster of heavy rainfall with the GIS. And then next, we analyze the effect of the ENSO phase on the rainfall characteristics by using the ONI index, which is the Ocean Ninjo Index. First, we analyze it with the total amount of rainfall for the whole season using the data from 12 years. And here we can see quite a clear trend for both negative and positive ONI. For the negative ONI, which imply the La Nina phase, the correlation coefficient show a negative value. So this can be interpreted that the more negative ONI, then the high amount of rainfall can be observed, which means that if the La Nina is strong, then we have more rainfall. Because the stronger La Nina, then the more negative value you can have with the ONI. So you can also see from this scatter plot that if the La Nina is strong, then we have more rainfall. And these relations are more obvious compared to the El Niño phase. The El Niño phase, we have less correlations between rainfall characteristic and the intensity of the El Niño. But still, you can see some correlations between the rainfall characteristics and the degree of El Niño. And we also investigate the rainfall characteristic for every 2 weeks to get more information or to get more details. And the results are quite the same. That for the case that we investigate for the whole season, that for La Nina phase, we see more correlations of the rainfall characteristics and the intensity of the La Nina. And another thing that we found is that the effect is quite instantaneous, which means that because here we analyze the ONI index at the time with the rainfall characteristic at the time too, and we also analyze the ONI index 1 month, 2 months, and 3 months before the time. And you can see that the correlation coefficient is can be quite strong without the lag time. So which means that once La Nina occurs, then it has direct effect to the rainfall in Thailand right away during the La Nina. But for the positive ONI or the El Nino, you can see that the correlation coefficients are quite similar for different lag time, which means that if El Nino occurs, then it could have prolonged effect to summer thunderstorm in the upper northeastern part of Thailand. Here we analyze the result for the average rainfall and also the heavy rainfall cluster area. So the results are quite the same, but for the heavy rain cluster area, you can see that for La Nina phase, the correlations are not very strong compared to the El Nino phase. So I come to the conclusion here that the effects of the ENSO the ENSO has effect on the rainfall characteristic in the summertime in northeastern part of Thailand, and the effect is quite clear in March and April. But in May, the effect is not quite clear, as you can see from the correlation coefficient. That in May, these statistics are quite low compared to in March and in April. And for El Nino phase, the results are quite prolonged. So if it's occurred, then it can have effect in a longer period compared to the La Nina effects. That once it occurs, then it has the effect right away. Okay, so these are the things that I would like to present here. Well, thank you very much.